Hi everyone, welcome back. This video is going to be a slight addition to my part 5 video on setting up a vectored thrust model. I had a request from a viewer in regards to how do they go about switching the vectored thrust on and off. And I hadn't considered it to include that facility in the original video, mainly because it's really just a setting within the functions menu, and I covered off the functions menu earlier. However, it's probably a good topic to make another little video, so I've decided to just do this follow-up video. So this will be part 6 in inverted quotes. So this video will cover off how do we go about switching the vectored thrust feature on and off. There's a couple of little tricks to be aware of. Now, shown in front of the camera at the moment, I've got my existing model which we used in the part 5 video, which covered off setting up a vectored thrust model. So again, just to refresh everyone's memory, the rudder stick, if I move my rudder stick, we have the rudder servo there in the center, and just to the right of it is my yaw servo, which controls the thrust vectoring nozzle. And if you remember from part 5 video, they both have to operate in the same direction. That's the correct sense. And same goes for this pitch servo over here. So this pitch servo is controlling the pitch or the up and down movement on our vectored thrust nozzle. And that's tied to my elevator stick. So you've got the two elevator servos up the top of the screen. So we've got up elevator, down elevator, and the nozzle follows the same, or basically the pitch servo in this example has to follow the same sense. So that's correct. And just to prove, I've still got the original setup. If I move the gyro, so let's move the gyro in an anti-clockwise rotation. So I'm going to rotate it in anti-clockwise in that direction. So these two servos should move off to the right. So let's try that. I'll try and do it as smoothly as possible. So they're moving in the correct sense. So they're correcting my anti-clockwise movement. And same goes for the pitch elevator control. So if I pitch the nose up, so I'm going to move the front of the sensor upwards, just like that. We basically have down elevator. So if the nose of the aircraft goes up, we have down elevator, as well as the pitch control on the vectored thrust moves down to try and point the tail in an upwards direction to counteract the nose up attitude. So that's all working correctly. However, how do we switch this off? So how do we switch the pitch and yaw servos off when we need to turn them off? So in normal flight, when you're not using vectored thrust, obviously we don't want these to be active. Now, it's pretty easy to switch these guys off. So we'll do that in the function menu, and I'll show you exactly how to do that. However, there's another thing to be aware of, is the fact that we can switch these guys off so they don't respond to any inputs on our radios. That's fine. However, just be aware that the gyro will still impact these servos, depending on what the gyro is doing. So even though we don't have any stick input, the gyro itself can affect these two servos still. So we also need to switch the gyro off just for these two guys. So we still want the gyro working on our rudder and our two elevators, and as well as our ailerons. However, we don't want the gyro to be operational when we switch off the vectored thrust nozzle steering, if you like. Okay, let's switch over to my core screen and I'll show you how to set it up in a few easy steps. Now that we have our main screen of the core in front of us, let's take a look at our functions again. So let's go into the functions menu, and you may be familiar with this if you've watched my previous videos. Down the bottom we've got the vectored thrust pitch, vectored thrust yaw, and the vectored thrust gyro gain functions. So these inputs are referred to as functions. And of course we've got other functions like the throttle, aileron, elevator. And over on the right hand side we've got the associated channel that they're operating. So in this particular case you can see that the vectored thrust pitch, which is operated by stick C, which is my elevator stick, is operating channel number 8. So the pitch servo for the vectored thrust nozzle is plugged into channel 8. Yaw is stick B, so yaw is my rudder stick, stick B, and that's controlling the servo that's plugged into port 9 or channel 9. And then we've got the vectored thrust gyro gain. So that gain is set to be operational on channel 26. So that's a bit like a virtual channel. That's only processed internally in the Mercury. There's no PWM, actual PWM output associated with that channel. Okay, so this is what I didn't show you in the previous videos. How do we switch these guys off when we don't want the vectored thrust nozzle working? Well, it's actually fairly simple. So if you ever want to turn a function off or modify a function, you can actually go into these curves here. So if you look at under this setup column, you've got this picture of a little curve, and that pertains to the relevant function that it's associated to. So for instance, let's have a look at the curve that's associated with vectored thrust pitch. So basically this is going to impact the servo that's plugged into port 8 or channel 8. So let's select the curve. Now, this curve here, remember it's our pitch, vectored thrust pitch. So when I move my elevator stick, you'll see the blue line move up and down, and you'll probably hear the servos in the background because they're still connected on our little model. And you'll notice the current response is a straight linear line. So basically, as I move my elevator stick away from center, the value of the actual servo travel basically goes down to the minus 100%. So that's full throw in one direction and then full throw in the other. So this is what our servo is responding to. Now, how do we kill that response? So basically we don't want the servo to move in a particular position. Now, you have to decide what you're going to use. You're going to use a switch or say flight modes. So there's two ways to switch it off. You could use, say, your flight modes, and that's probably a convenient option for many. Or if you just want to use a switch, I'll show you how to use a switch. I'll show you how to use both. Let's try flight mode. So flight modes is pretty easy. I haven't actually got any set up at the moment, but all you need to do is basically change this option up the top here from global to single. So it comes up with a warning. Now with single, basically these settings on this page will change with every different flight mode that you select. So you can have a takeoff landing flight mode, and basically we would adjust the pitch servo not to move. And you'd only have it, say, in your 3D aerobatics mode, for instance. So that's how you enable the flight mode switching for this screen. Again, make sure that's set to single, and all these parameters will be adjusted per flight mode. So you may not want to do that. You might just want it on a switch. So let's pick this guy here, this switch here. So we'll go back to global. So global now just means the one setting for all the flight modes. But we want to use a switch. So let's select this switch. So we go into this thing here called control rate, and we select an input device. So let's select the switch. So switch J. Click on OK, and you'll notice switch J is now in the screen here. And let's have a look at this rate option here. So at the moment it's set to 100%, and you'll notice box number 3 is highlighted. So as I switch the switch through its 3 positions, this is a 3-position switch, watch what happens to the green box. So that's the center position of the switch, and that's the switch position closest to the pilot. Just be aware that I've reversed the sense of my switches in the hardware options, so it might be opposite in your radio. So in other words, this might be position 3 on your radio, that's all. But effectively it's the same thing. So we can now switch through 3 different rate options with this switch. Now remember, when we have 100% rate, that's the normal servo's rate. So in other words, it's normal operational range. However, let's say, for instance, we want, with the switch fully forward, we want the thrust vectoring to be switched off. Well, all we need to do is adjust this rate. And we'll just adjust it to, say, 0%. And watch what happens to the straight line curve. So this is similar to like a dual rate function, basically. But we're going to set it to 0%. So there's actually going to be no travel available for this servo when switch J is in this fully back position. So in switch position 3, I've got 0% rate. If I bring it forward to the center position, we have 100% rate, and that's its normal servo rate. and I'll show you the servos moving and not moving later on. So basically we now have the pitch servo disabled in that position, and if we want thrust vectoring for the pitch servo to be operational, the switch needs to be in the center position. Easy as. Now all we need to do is do the same thing, however, for the yaw servo. So let's try that. So for the yaw servo, we move out of this function. So remember we were in the pitch function, so vectored thrust pitch. We now need to go into the curve for our yaw servo, which is channel 9. So we select the curve, the function curve, not the servo curve. So let's select the function curve, and we do the same thing. So remember, if we want to use flight modes, select single up here, and all these settings will be set per individual flight mode basis. However, we're just going to use a switch. Now let's select our input device. So we're going to use the same switch because we don't want to confuse the pilot too much. You don't really want two different switches to select between yaw and pitch disabled. That might make it a bit tricky for the pilot. So we'll use the same switch, and we'll do the same thing in position 3. At the moment we've got 100% on all 3 positions. So I want my thrust vectoring to be disabled in this position. Let's reduce the actual output rate for this channel to 0%, which basically means there'll be no output for this channel when the switch is in this position 3. So again, if I flick it to the center position or the fully down position towards the pilot, we have normal thrust vectoring enabled. However, switch fully away from the pilot, there is no servo action. So the servos will just be stuck in their center position or their neutral position. So hopefully you're following that so far. Now, remember how I mentioned that if we disable the servos, the gyro will still be functional. So currently now we've disabled the servos. So with this switch position fully back towards the back of the transmitter, the pitch and yaw servo do not operate at all. There is no movement, and we can actually just go into the servo monitor screen for that. So if we have a look here at, here's our channel 8 and channel 9, so we've got pitch and yaw. So if I make them operational, let me move my elevator stick so you can see the pitch servos moving with the elevators there, no problems. And if I move my rudder stick, you'll notice the yaw servo, we have an output there on the yaw channel as well. So basically the two servos, the rudder and the yaw servo, are moving. In other words, our vectored thrust nozzle is moving in the yaw axis. However, let's disable it. So all I need to do is flick the switch fully back, or fully forwards, back to the back of the transmitter I should say. And now if I move my elevator stick, you'll notice just the two elevator servos are moving, but there's no pitch servo moving. It's disabled at 0%. So basically it's center of travel. And the same goes for the rudder now. So I can move my rudder stick, and you'll notice the rudder is moving, and the yaw servo is stuck at 0%, simply because we've got this in the disabled position. So that physically disables our pitch and yaw servos when the switch is fully back like that. Easy. So you think, okay, that's it. That's all we need to do. However, just be aware that the gyro is still operational. So as the plane moves, the gyro itself can still feed an input into the pitch and yaw servos. So even though the radio doesn't have a stick input, so the stick inputs are disabled for those two servos, for your vectored thrust nozzle, the gyro itself can still put an input, and we don't want that. We don't want the nozzle to be working at all. We just want it to be pointing pretty much straight out the back. So it's pretty much the same thing, but it's just something you've got to be aware of. So remember our gain for the gyro. At the moment I've just got it on a rotary control, and I can adjust it there, so you can see it adjusting there as I move my rotary control around. And let's leave it on 30%. What we need to do is disable this as well. So imagine this is just a servo output. So no different to our previous, oops, I went back too far. No previous to what we did to the pitch and yaw functions. We do the same for the gyro gain. So the vectored thrust gain. So this is not the overall gyro gain. So the overall gyro gain is set on channel 10, but we do have a separate vectored thrust gain for the gyro, and that's on channel 26, and we've got a curve for that as well. So let's do the same thing. So as I vary the rotary encoder, you'll notice the blue line will move from left to right depending on how far I rotate the actual encoder. So that's fully clockwise, and that's fully counterclockwise or anti-clockwise, and that's pretty much the center. So again, we do exactly the same here. Remember, if we want it to be disabled using flight modes, we just change that flight mode setting to single. However, we're just going to use a switch for this example. So again, select the same switch. Good idea to select the same switch. And pretty much exactly the same thing. We've got the three options. You've got the three different rates. So with the switch fully forwards or backwards, depends if you're standing behind or in front of the transmitter. In position 3, let's make it 0%. So let's reduce it down to 0. Click on OK. So what's going to happen now is the vectored thrust gyro gain is going to be 0% when the switch is in this position. If I flick it back one position, it's now enabled, and it's going to give us 100% rate. But don't forget that 100% rate is the 100% of the gyro setting set by the rotary encoder. So if let's go to the servo monitor screen. So you'll notice we've got 0 in both positions because I've reduced the knob. Let me adjust it to say we've got 30% gain. I've just set the knob to 30% gain, and that's with the gain enabled, or the vectored thrust nozzle enabled. If I flick the switch back, you'll notice it switches to 0% now, and that's because of that function curve setting where we set the rate to 0%. So 0% basically locks the channel to the center position, which in this case is just 0% gain. So again, flick it up. We've got 30% gain on our vectored thrust nozzle, and if I scroll down a little bit more, and I'll show you the servos in a minute, if you look at our pitch and yaw servo, so if I move the pitch servo, and let's give it a bit of rudder as well, you notice they're both moving. Let's flick the switch off. So vectored thrust is now switched off. We've got no more pitch control, and there's no more yaw as well. And if I scroll down without touching anything, you'll see the gain for the vectored thrust. So this is only the gain for the vectored thrust is set to 0%. Okay, let's have a quick look at the servos. So now we can see the servos, and I've included a little bit of the screen here, so I want you to keep an eye on this vectored thrust gain channel. So at the moment we've got 30% on both the vectored thrust and also the standard gyro gain. So this is impacting our ailerons and elevator and rudder. However, it has no impact. This gain here has no impact on the actual vectored thrust nozzle. The actual vectored thrust gain, which is a separate gain channel for the gyro, controls how much gain is specific just to the vectored thrust servos or the vectored thrust nozzle. So I've just got them both set to 30%. So you'll see when I switch this switch, it drops to 0%, so there's 0 gain on our vectored thrust servos, and you'll see how they'll be disabled. So let's enable them. So flick that switch. So remember, we're changing those 3 function curves, one for the pitch, one for the yaw, and one for the vectored thrust gyro gain. So when it's disabled, the rate for that channel is set to 0%. At the moment it's enabled. At the moment it's enabled, so we've just got normal gyro control. So let's go through. So there, I'm moving my elevator stick. So you'll see the pitch servos moving in conjunction with the elevators, both in the same direction. And then we've got the rudder as well. So I'm just moving my rudder stick to the right, and you see we've got deflection there. So again, moving the actual gyro sensor. If we rotate this, you'll notice we've got the vectored thrust yaw axis is moving because I'm just rotating the sensor anti-clockwise and clockwise a little bit. And if I tilt the sensor forward and backwards, we should get the elevator servos as well as the pitch servo moving in basically the same directions. So it's basically trying to correct. And you'll see the rudder servos are wobbling a bit because I can't hold the sensor that smoothly. So that's just me. Okay, now let's see what happens. So remember, I've got full control of both my normal flight surfaces plus the actual pitch and yaw axis of the vectored thrust nozzle. Let's now flick the switch and disable it. So now I've flicked the switch fully back in that direction. Let's see what happens when I move the elevator stick. So now I'm just moving the two elevator halves. However, you'll notice the pitch servo is not moving at all. And same goes for the rudder. If I move the rudder stick, now we just have basically the rudder servo moving. And no yaw action on the vectored thrust nozzle. And of course, since we've also disabled the gyro gain, if I put in some yaw movement, it's only impacting the rudder servo, so that's controlling our rudder in the correct direction. However, the yaw servo's fixed, it's not moving, which is what we want. And if I tilt the sensor, we now have the elevator servos moving in a bit of a haphazard way. But again, that's just me hand holding the sensor. And the important thing is to note that the pitch and yaw servos are fixed in their center position. So that's it. A quick and easy way of disabling or enabling the vectored thrust nozzle, all by a flick of a switch. And like I said, if you don't want to flick a switch, in this situation you want to tie it to your flight modes. You just select, instead of global, you select single, and you set those rate settings per flight mode. Basically, you can reduce the rate. You can even include a switch with different flight settings. It gets a bit complex, but it's easy enough to do with either flight modes or a single switch, and pretty much that's it. That's how you do it. So hopefully you've learnt a little bit on how to basically disable the vectored thrust correctly. Okay, thanks for watching and stay tuned for the next video.